How will we aggregate taking the lead in developing new sites? They'll have to build policies under which farmers find it useful to transfer land for large scale solar.
Welcome to this episode of Sustainability Karma. I'm your host Naina Gautam, and today we have with us Dr. Ajay Mathur. He is the former Director General of International Solar Alliance. Presently, he is working as Professor of Practice at the School of Public Policy at IIT Delhi. Welcome to the show.
I'm delighted to be with you.
What is your assessment of last 10 years of solar progress in India?
First of all, Naina, I think that this is like a solar revolution because we have moved from being roughly marginal. In 2014, we had about 2.8 gigawatts, 2,800 megawatts of solar, and today we have crossed the 150 gigawatts mark. So in 10 years, we've grown from 2.8 gigawatts to 150 gigawatts. This is huge. In my view, this 50-fold increase that you see is because of very strong policy signals, of the ability of policy to learn from the situation on the ground and make tweaks in the policy accordingly. We also saw the PLI scheme come in, which has enabled domestic manufacturing and therefore has helped in the reliability of supply chains. And I think most importantly, the competitive bidding process, moving from the old scheme in which there was a reservation for under the renewable portfolio obligations to competitive bidding has been the major reasons why we have seen the solar capacity go up 50 times, and at the same time the price has dramatically reduced to the point where now the price of solar electricity plus batteries, so solar round the clock, is the same or equal or maybe even less than that from coal-based electricity.
Recently, the government has announced targets for the year 2035. How do you see the new targets?
I think what is important is not how we reach the target, but more importantly, how do we integrate this capacity efficiently? 2 weeks ago, when we had the maximum demand of 252 gigawatts on one day, the biggest challenge was solar was available during the day, but what happened at night? So as we move ahead, the challenge is this cannot be on the basis of vanilla solar alone. This will have to be based on providing access also to batteries. It will also be based on the availability of adequate land, the fact that we can build transmission lines to these solar plants at the same time as the solar plants are commissioned, and the fact that we have adequate first-time financial resources that are needed for setting up the solar plants. Because while the solar electricity is cheaper, the first cost is still much more than the cost of fossil fuels.
As per Niti Aayog, to achieve net zero goal by 2070, approximately 5,000 gigawatt of solar is required. But solar is land-intensive technology. How do you think we'll achieve this capacity?
In my view, there are four kinds of things that can happen. The first is states will have to work on taking the lead in developing new sites for solar. So they'll have to build policies under which farmers find it useful to transfer land for large scale solar. So right now it's really developer goes there, he promises things, the state does not get involved. So I think that's one of the changes we'll have to do. The second is see wherever there is a water surface, for example, there's a dam reservoir, we can put floating solar there. You've seen floating solar come up near for example, outside Kochi, there is the power station, old gas-based power station, which had a large reservoir, and there is hundreds of megawatts of solar that was put there. This was the first one. After that, there have been several more. So I think we will have to use all water surfaces. Third, we will have to focus on much more on doing agrivoltaics, which is do it on top of agricultural land, so that the farmer gets double the income. One, he gets from his agricultural income, and two, he gets from the sale of electricity that is generated. Now, there are questions, of course. What will grow under a solar plant? Cereals don't, tomatoes, chilies do. We need to find out in different agroclimatic zones what is it that will grow. We also need to find out how will we aggregate the various solar plants that are put up and feed to the grid. Because connecting each individual solar plant to the grid may become difficult, so we have to aggregate it. And last is that we'll have to give a lot more importance to solar rooftops. So we have seen it growing. It's at about 35,000 megawatts now, 35 gigawatts. We will have to increase it dramatically in order that it also makes a huge difference. In between these, I believe we can make all the land that is available.
What do you think of installed capacity versus generation mix?
You are absolutely right. Today, while the installed capacity is pretty high, I mean, it's solar, all renewables are something of the order of 52%, renewables alone, solar alone is something of the order of 30%, but as far as generation is concerned, it's only 17%. So, very, very clearly, moving ahead, what we need to focus on is we've set up enough capacity so that during the day when the sun is available, it charges batteries, or we use it for pumped storage to move water from a lower level to a higher level, so that when the need be, that pumped storage or batteries or other storages can be utilized instead of the solar not being available at that time, or wind not being available at that time. In other words, storage is essential.
Indian grid, with less than 20% with solar in generation, is already showing the duck curve. Challenge. People say that storage is the solution. What do you have to say about it? What do you think of the financial aspect of it?
So, first of all, I completely agree that the only way we can address the duck curve is by adding more storage. The battery energy storage costs have dropped dramatically to the point where battery plus solar produces electricity at a cost which is less than the cost of coal. That has happened. But nevertheless, the problem is the upfront capital. Where do you get the upfront capital from? And therefore, the government subsidy, the viability gap funding that they are providing, is something that will make it a lot more viable. It will happen. And it makes it a lot more attractive to the distribution companies as well. What is important is that as we go ahead, we ensure that the first costs are met. Now, the first costs could be met largely by Indian money. There could also be some amount of international money. But Indian money finds it difficult because they've got a lot of exposure in this particular technology. So we will have to create a market for it. When can we use battery power and how? What will we pay for it? And on the other side, provide contracts which have both solar and battery together. This will pull in the capital requirement that there is for solar plus battery plants to go ahead. It will also enable the viability gap funding to go ultimately to zero.
I've been reading about BESS a lot and I think it's at initial stage. So maybe it will take 5, 10 years or maybe more. So what's your take on that?
Quite possible that even by the end of this year, except the financial availability part, we will probably see BESS maturing both technically and financially. The challenge, of course, is that most of this battery development occurs in one country, China. We would need to push this development in our own country so that not only the manufacture of batteries occurs, but that it is constantly upgraded as time goes by.
How will we manage the huge investment required for storage and transmission infrastructure?
There are two kinds of things that happen. One is that if the cost is levelized to begin with, and the levelized cost is cheaper of the new technologies, which it is, then it will happen. But the first cost is higher. So in order to get the first cost, this makes it attractive for banks to lend money. But banks are unsure because they're providing a huge amount of exposure. They need to get their money back and money back on time. So therefore, timely repayments are important. It would greatly help if guarantee type instruments can be set up, which provide confidence to the banks to lend the first money that is needed for these plants to occur.
You have joined a premium institute in the country. How do you see the role of such institutions in transition to solar?
I am at the School of Public Policy. So I work very closely with the Department of Energy Sciences. And therefore, I believe that the technological support that institutes like IIT Delhi, but IIT Bombay, IIT Chennai, etc. can provide. The first is developing better solar cells. So IIT Bombay has already used perovskites in the solar cells that they've made. I think pushing more and more of perovskite-based solar cells is the way to go in the future. The second is policy support. We have been providing both data and models and regulatory inputs that are needed for the policies to keep track of upgraded technologies. So that's the second. But ultimately, IITs, like other educational institutions, are about providing people. So human capital is our most important contribution to the sector. Think of it like this. Tomorrow, if all the electricity in India is based on, or the vast amount is based on solar and batteries, there's no need for rotating machinery. Therefore, engineers who are the electrical engineers managing this system have to be familiar much more with power electronics than with rotating machinery. Where will they be taught that? In the IITs. And then hopefully in other academic institutions as well. In my view, innovation, policy support, and human capital development are the three ways in which educational institutions can help move us to the next level as far as solar energy is concerned.
You just mentioned peroxides and there is not much talk about it. It's at a very niche stage.
Lab experiments on perovskites have shown perovskite is a new material. So what it has shown is that we can get efficiencies of more than 30% with perovskite-based cells. Right? The problem is that when perovskite is opened up to air and moisture, it degrades very fast. So, for example, what the IIT Bombay innovation did was that they encapsulated it. They put it within a semiconductor base. And so You had semiconductors on top and you had perovskites at bottom. But in the process, you got much greater efficiency because you're having efficiency of semiconductor and you're getting the efficiency of perovskites. We believe that day after tomorrow, what we will be getting is 100% of perovskite-based solar cells. The linkage between industry, which right now focuses on technology imports, and the R&D sector in India, which is the educational institutions plus the R&D hubs of the companies themselves, they start becoming much more active. The only way this can occur is that since we have a plan, we also say that we will procure. Right now the most efficient solar cell is about 24%. So by 2030, we will say procure 27%. By 2035, say we will procure 30% or something of that sort. In other words, there are multiple goals for multiple years. This is said right in the beginning. This will make it very difficult for industries who are currently supplying solar cells to go in for technology imports again and again and again. That's number one. Number two, it will push them to invest in R&D capacity within the country. And number three, it will build up, particularly for the longer time frame, it will help build up the academia-industry partnership that is needed for this change to occur.
Today's conversation reminds us all that the energy transition is not just about technology but about long-term vision and collective action.
Such a pleasure. I am actually absolutely delighted to be with you, and also it was stimulating to see the kind of interaction that occurred. It really stimulated me. Thank you very much.
Until next time, this is Naina Gautam signing off for Sustainability Karma.
I hope you like this program. We look forward to your feedback on our WhatsApp number 9818120554. For participation in this program, write to us at sustainability.karma@gmail.com. Looking forward to meet you again at the same time next week with a new episode and a new guest. Till then, goodbye from all of us. Sustainability Karma.